Hello, and welcome to my YouTube channel. If you are, like me, not just a maths enthusiast, but want to understand the impact and applications of mathematics to the world around us and beyond, you are in the right place. In this video, I'm going to talk about the maths behind AI, specifically how ChatGPT knows how the words we are typing in relate to each other. In short, how ChatGPT knows what it means. Let's make a start. This is the dot product formula for vectors, and one of those early topics we learn in our AS level further maths. But did you know this is also what runs ChatGPT, Claude and Gemini? Not metaphorically, literally. Every time you type a message, a version of this runs hundreds of millions of times. Let me show you how. Read this sentence. The cat sat on the mat because it was tired. When you got to the word it, your brain knew it meant the cat, not the mat. Obvious. But for a computer, this was almost impossible for decades. It's called the coreference problem, figuring out what a pronoun refers to. In 2017, a paper called Attention is All You Need cracked it. That paper is the reason AI today works the way it does. And the core idea inside it, the thing that solved one of the hardest problems in computer science, is something you've already done in maths. Obvious. "30 seconds of grounding for anyone who hasn't met the dot product. Two vectors come in, one number comes out. That's why textbooks also call this the scalar product. There are two ways to compute it, and they give you the same answer. The first is the component form. Multiply matching components and add them up. The second is the geometric form. Magnitudes times the cosine of the angle between the vectors. Same answer, two faces. Quick worked example. Vector A is 3, 4. Vector B is 2, 1. Component form. 3 times 2 plus 4 times 1. 6 plus 4. 10. Now the geometric form. The magnitude of vector A is the square root of 9 plus 16, which is 5. That's just Pythagoras. Magnitude of vector B is the square root of 5. Do the trigonometry and the angle between them comes out to about 26.5 degrees. 5 times root 5 times cos of 26.57 degrees gives you approximately 10. Same answer, different root. This is why further maths actually teaches the dot product. Rearrange the geometric form and you have a formula for the cosine of the angle between any two vectors, straight from their components. Hold that idea, cosine of the angle between them, in your head. We're about to use it for something much weirder than finding angles. Forget angles for a second. Look at what cos theta actually does. Same direction, cos theta is 1. Dot product is at its maximum positive. Perpendicular, cos theta is 0. Dot product is 0. Opposite, cos theta is -1. Dot product is maximum negative. Forget that this is an angle calculator. The dot product is a similarity score. Big positive, similar, 0, unrelated, negative, opposite. Watch it happen as B rotates. That's the reframe. The dot product is a similarity score. Hold that idea. The rest of this video is just that idea, scaled up. To use the dot product to compare meanings, we first have to turn words into vectors, which sounds mad. But it works. The word king becomes a list of numbers, a vector. So does queen, so does banana. These are called embeddings, and here's the magic. The model is trained so that meaning becomes direction. Words with similar meanings end up as vectors that point in similar directions. King minus man plus woman approximately equals queen. Subtract the male royal vector by removing man. Add the female component by adding woman. You land roughly where Queen lives, meaning as maths. This is the trick that makes the entire next bit possible. Back to our sentence. The cat sat on the mat because it was tired. Every word is now a vector, including it. The model's question is, for the word it, which other word in the sentence is it most related to? Cat or mat? Here is what it does. Ready? It takes the vector for it and dot products it with every other word's vector. Those numbers are called attention scores. They are literally telling the model, pay most attention to cat. That's how it gets resolved. Not by grammar rules, not by a dictionary, by dot products. And the model does this for every word in the sentence, in parallel, looking for the highest match. And what we just did was it against two other words. The model does it for every pair in the sentence. Small caveat. Real GPT doesn't use one vector per word, it uses three. Query, key, and value. Same operation, slightly different roles. But the core move. Take two vectors, dot them, use the result as a weight for how much one thing matters to another, is the engine. 1,000-word prompt means 1,000,000 dot products in a single attention layer. GPT has around 100 layers. You just ordered 100 million dot products for one reply. People ask me why I love maths. It's this. A formula that is 200 years old turns out to be the engine of the most consequential technology of our lifetime. Nobody planned that. The maths was just waiting. Next episode, how the model learns those word vectors in the first place. Spoiler, it's differentiation. This is the maths behind it. Subscribe so you don't miss it. I'll see you in the next one.
It's the math behind